So case one, we know sigma for both populations. Okay, so what that means is that the information, right, the information that we have, right, is x bar 1. Right, we have x bar 1 and x bar 2. Of course, we need to approximate, or we need to estimate the sample average, or sorry, not the sample, we need to estimate the population average for both of these. Okay, so for some reason we have sigma 1 and sigma 2. Okay, and then in our sample, of course, we have n1 and n2. All right. Now, suppose we have all these information, okay, then we can proceed, right? So the sampling distribution of theta bar, right, is this. So again, just as a reminder, right, theta equals mu1 minus mu2. Okay, that means the difference between the two population mean. Okay, we're using theta bar to estimate that. So our estimator is theta bar equals x bar 1 minus x bar 2. Okay, now, so if theta bar is normal, meaning normally distributed, okay, then we have this. We have a normal approximation. Okay, so look at the previous page for our condition for approximately normal, right? So theta bar is normally distributed, centers at 0, because the null hypothesis we're focusing on is that the fact is that these two are the same. So the difference will be 0. Okay, then the standard error of theta bar equals square root of the variance of the first population plus the variance of the second population divided by the sample size. Okay, this is similar or analogous to the standard error that we worked with before for x bar, actually, right? Which is sigma over root n. Okay, so this is basically the same way. We just calculate. You can look at that as kind of an average, right? Kind of a weighted average. All right, now, okay, and that's it. Once we have that, then our test statistic, okay, it's very simple. Theta bar minus theta naught over standard error of theta bar. Okay, now our theta bar, our theta naught, right, it will always be 0, at least in our class. Right? Because right now all of our hypothesis is asking if there is a difference, right? So then this kind of leads to the way we'll calculate our test statistic will basically always be just theta bar divided by the standard error of theta bar. Confidence interval be theta bar minus e, and theta bar plus the margin of error, and the margin of error, right, it's just as we did before, will be z alpha half times the standard error of theta bar. Okay, all right, so everything should look very familiar, right? The only change is how we calculate that standard error there. Okay, let's do an example of a case 1. Right, here the hypothesis is mu1 minus mu2 is less than or equal to 0. Right? Another way to write this would be mu1 is less than or equal to mu2. Right? We're saying that the average in population 1 is less than the average in population 2. Okay, and here's the information that we have. So here's indeed we have sigma. Okay, now before we proceed, check for normality. Right? Do we have approximately normal distribution? Okay, here both of these are greater than 30, so we don't need to make an assumption that the both population are from normally distributed populations. So we can go ahead and draw that. Theta bar is there. Then this is center at 0. Okay, next our theta bar equals x bar 1 minus x bar 2, which means it's 25.2 minus 22.8. 2.4. Okay, all right, so then that's our test. That's our not test statistic yet, right? So we want to see, where 2.4, right? Where 2.4, right? How far is it? So in order to do that, we need the standard error first. Square root. Okay, I'll just copy down the formula here again. Okay, which equals, and feel free to pause if you want to try to fill it in yourself. Okay, and here this is going to equal to 1.18. All right, so now let's look at our test statistic. Then our test statistic will equal here, part A. Okay. So our test statistic is going to be 2.4 minus 0 over 1.18, okay, which is 2.034. All right, so that's how far that's how far that is, 2.034. Okay, and then now, nice. Now, so A tells us we're going to use the critical value method. Okay, that means we want to compare here. Right, this is a right tail test. Okay, because it's less than or because it is less than or equal to, right? So put alpha here, which equals 0.05. So here is the critical value, z alpha. Okay, and we looked that up before. Right? That's 1.65. Okay, our test statistic, t falls here, right, in the rejection region. So our t, okay, our t is greater than our z critical value. Therefore, we reject the null hypothesis. What is our null hypothesis? Our null hypothesis is that mu1 minus mu2 is less than 0, which means we support that mu1 minus mu2 is greater than 0. Right? In other words, reject the null hypothesis. Therefore, right, we can make a statement like so. There is evidence. Right? There is evidence, right, showing that mu1 is greater than mu2. Right? Okay. All right. Now let's try the p-value method and see if we get the same. Result. Right? So p-value method is, okay, just go ahead and do a quick sketch here again. Our test statistic is 2.034. Right? That's our test statistic, and what we want is the area to the right of that. Right? This is since this is a one-tailed test, right, we just want the one side here, so that area is going to be our p-value. Okay, so use your app, look that up, and what you will get is 0.0221. Okay, all right, let me show just a refresher. Right, if we look at here, just make sure you go to normal distribution, okay? And then remember, since we're dealing with test statistic, right, make sure that this is 0 and that is 1, okay? The test statistic it's a standard normal distribution, okay? Well, we just type it in here, 2.034, and we want the right tail, so put in the right tail there. All right, okay, so there we go. All right, let's go ahead and round to 3 decimal places. 0.021 it is, okay, and we'll see we get the same result, right? P-value. So here our p-value, right, our p-value, it is less than alpha. That means our observation is extreme. So our observation is extreme enough that it's so extreme because it's such an unlikelihood that null is true that we are going to reject, right, reject the null hypothesis as well. Okay, and again, these two always equal, or well, I'll say always give you, not equal, but always give you the same conclusion. All right. Okay, so go ahead and take a minute and read the question carefully. All right, and the first thing you want to do is copy down, write down the information in a clear form right here. Okay, so you should read the question. So population 1, right, describes the group that has, or the group of the service, or the group of the ships that carry fewer than 500 people. Population 2 carries more than 500. Okay, and here's the average right, rating for both of these populations. Here's our estimate, and here we have the population standard deviation. Okay, so that is our case 1. So let's start with A. All right, what is the point estimate for the two groups? All right, so our point estimate is going to be theta bar x bar 1 minus x bar 2. Okay, that is our point estimate, right, for the difference, right, in the two. Next, at a 95% confidence, right, at a 95% confidence, what is the margin of error? All right, so B. Okay, again, remember, margin of error equals the critical value, right? The critical value times the standard error of x bar. So now we need then the standard error of x bar. So okay, so I'm going to skip the writing the formula. I'm just going to go ahead and straight copy the number down. So that's 4.55 squared. Okay, go ahead and put that in the calculator. Okay, so what we get here is 0.95958. Then our margin of error equals 1.96. We looked that up before already. Okay, times 0.958 equals 1.878. Okay, it's our margin of error. Now let's get our confidence interval here. Okay, so our 95% confidence interval for what? For the difference, right, between the means. Right, basically means mu1 and mu2. What is the difference between them? Right, is our confidence interval would be 3.96 minus 1.878, comma, plus 1.878. Okay, then all right.